Can you tell me how the lungless salamander breathes?
Through their skin.
They breathe through their skin.
Really
Aenetes vagrans. Ever heard of vagrant seeds? They have to be at cold. As far as these guys are concerned, your hand is a frying pan.
Yeah. So is this the same kind you see under the rocks at your house?
You can, yeah. The genus Batrachoceps, the slender salamanders. This is what you see alongside the river. This is the aquatic garter snake, Thamnophis atratus.
Can we hold this one?
Well, if you don't mind washing your hands after it takes a dump on you, this is the Pacific gopher snake. A big one of these around here can easily be 5 feet, going on 6. This is a young, yes.
I think that's what
This is what we call the opaque stage, about 2 weeks before they shed. You can touch it if you want.
She doesn't want to, but
Yeah.
well, you're so brave.
He's actually
It's like saw.
Yeah. You'll note the rather milky cast you see on the pattern. Well, that will clear. This is the Pacific rubber boa.
And they're great in your garden.
Exactly. This is our own local species of boa.
I don't want to be the first one to hold it again.
Oh, it's great.
She will not hurt you.
I want to be the last one.
She doesn't even
Or
hiss.
he. Yeah, no, these,
She doesn't bite.
they never bite.
The boas.
Unless you happen to be
Very mean.
a baby rodent.
Very bad.
Very colorful, kind of an olive brown, sometimes a greenish brown, and that beautiful butter yellow underneath.
It is so pretty. Really,
Yeah.
the scales are really small, so it's like super.
Be gentle. Be gentle. Isn't that beautiful? Our own species of boa, and they do well in captivity. The last several vertebrae in the tail have collapsed into kind of a club-like apparatus to give this blunt appearance. What these guys do, they'll roll up into a little ball, hide their head underneath, and they'll stick the tail up and wiggle it around, and this looks like a head. And they use this to lure away the adult mice when they're feeding on the newborns, which is the only thing they can really handle. They also use it, when they're under attack by a predator, they'll wave this around. I'm Michael Dunkelberger. I work as a biologist down at Humboldt Redwood Company, one of the local timber companies. You may ask, what do we need biologists for? Well, with our habitat conservation plan, we picked out 4 species of amphibian and 1 of the reptiles that we thought could wind up on the endangered species list at some point in time. The foothill yellow-legged frog, the northern red-legged frog, the tailed frog, the southern torrent salamander, and the western pond turtle. Now, if any of you have seen turtles along the Van Dusen River, have you? Mm-hmm. That's the western pond turtle. And these are all species that we think, are in some form of decline. Now, how many of you have seen tadpoles in some of our faster mountain streams clinging to the rocks like an abalone, with kind of a light tip on the tail of the tadpole? Ooh. That would be the tadpole of this species, the tailed frog species. These guys like cold, fast water, and those tadpoles often cling to rocks in the fastest water because that's a place where they can stay. Okay, and this is the southern torrent salamander. Now, this salamander is very important to us for 2 reasons. Considered species of special concern, it also is an indicator species. So an indicator tells us something. Okay, if we have good populations of this salamander in the streams that we find it in, that means we have the same clear, well oxygenated, clean, cold water that's salmon and steelhead-like, which is a major fisheries, also imperiled by past logging practices. And well, another thing that's going on is drawdown of water by marijuana grows. That's getting to be a serious problem with some of the smaller class 2 streams that we find these in. You take away the water, salamanders, this species especially, no water, no salamanders. They're gone. Basically have 2 classes of vertebrates involved that I'm talking about, and that's the study of the science of herpetology. What we have here locally are salamanders, frogs, and toads. What's the difference between amphibians and reptiles?
Reptiles are like lizards and stuff, and they don't always need to be in water, and
Exactly.
amphibians need to be in water.
Exactly. They have to be moist at all times in their life. They always have to be in contact with some form of moisture. Now, how many are of the belief that salamanders all live in water? Amphibians have no real body covering. Now, what am I talking about? Body coverings. We're talking about things like scales. Anybody else with what a body covering could be? What do we see on other animals?
Fur.
Fur, hair, you bet. That's a body covering. And how about the birds? Feathers. But amphibians are without any such thing. So you might see newts, the ones that, the orange belly ones with the rather bumpy skin. That's not really a body covering. That's just a whole bunch of tiny glands. There is no body covering. The major difference between amphibians and reptiles and all the higher vertebrates is amphibians do not have to drink to get their water. All they have to do is sit in it. Their skin allows free movement of water in and out. This is why when they're exposed to hot and dry conditions, they dry out very quickly and they're dead. But as far as salamanders go, there's only 4 species that require a body of water to breed in. Okay, so the Pacific giant salamander, the northwestern salamander, the newt, and the southern torrent salamander, those are the only 4 local salamanders that breed in the water, that need to have water, either a pond or a stream or a lake, to breed in. Snakes,
Reptiles.
alligators, any others? Crocodiles, yes, absolutely. Close related to the alligator. How about one other that we see along the rivers around here? Turtles. The basic difference between amphibians and reptiles: amphibians, no skin covering, and they have to have some form of moisture, be in contact with some kind of moisture at all times. Reptiles, on the other hand, what do they have to do to get water in their system?
They have to drink it.
They have to drink it, just like we do. How many have seen a snake, sucking up the water? You have? Yeah. You? Yeah. Okay. Now this is a species that is very common in the old-growth redwood forest. Yes?
It's on the top of the tree.
Exactly. So this is the wandering salamander, formerly the clouded salamander. The clouded salamander, which is north of the Smith River, and this used to be considered the same species. They are actually very closely related sister species, but they are so closely related, the only way you can tell the difference between them is to know where you collected it, or do DNA tests to see what it is you exactly have. You and I are what we call warm-blooded. That means our body temperature is way more than that of our surroundings. Amphibians, on the other hand, are cold-blooded, what they call poikilothermic. That means their body is the same temperature as the surrounding air. If it's 70 degrees, they're 70 degrees. And if they're 70 degrees, they're dead. The salamanders have to be 50 degrees or less to be happy. And the plethodon, they have a very slimy skin. They're always, very wet to the touch. They have to be, otherwise they don't breathe. The plethodon do not have a larval existence in the water. Their larval existence takes place inside the egg. And when they hatch, they're a perfect little adult.